These peaceful waters off the east coast of Sardinia were the scenario of a critical test for the European Space Agency. A full-scale splashdown of Europe's intermediate experimental vehicle prototype. The IXV is Europe's answer to one of the most challenging operations in space business.
One of the most difficult things in space business is re-entering the atmosphere. So we are building a technological demonstrator that will allow us to experiment some key critical technology like the thermal protection system or the guidance and navigation control of this re-entry vehicle, which has, by the way, a very advanced lifting body shape, and is something that Europe has never done before, and so it is a very challenging project.
The real vehicle will be launched next year on ESA's Vega launcher into a suborbital path, testing new European re-entry technologies during its flight. And much of that success will depend on what happens during the final splashdown test.
What we are going to do now is the last phase from the main chute deployment down to the splashdown, so the ejection of the panels which are covering the flotation devices, then the splashdown, the inflation of the balloons, and the cut of the parachute and waiting for recovery. So we will be able to download not only the data through telemetry, but also the hard data stored on board.
It's the early hours of test day and the weather conditions couldn't be better, but it's difficult to camouflage nerves.
The plan is to go out now and free the field, and then the helicopter should go and pick up the prototype, reach a certain point at 3,000 meters altitude, drop the system and perform the test.
After the initial free-fall phase, the parachute slowed IXV for a safe splashdown at a speed below 7 meters per second, proving that it can be recovered safely after its space mission. Only one thing didn't go according to plan: the inflation of the balloons.
The positive part of this non-inflation of the balloons is the fact that the threshold we set in the software to detect the splashdown is probably much lower.
This was confirmed by the post-flight analysis, which revealed that the soft landing was caused by an overperformance of the parachute, which is prepared to deal with much heavier impacts. Atmospheric re-entry is a cornerstone for a wide range of space applications, including space transportation and planetary exploration. With next year's Vega launch, IXV will not only set an important milestone in Europe's path to future autonomous atmospheric re-entry vehicles, it will also demonstrate Vega's potential for commercial exploitation.